Okay, hello everybody again. I think we can start now. There's still some attendees that are missing, but they will join us so we don't waste your time. Thank you everybody, first of all, for making the time, finding the time to register and joining me on this webinar. I'm very grateful. I know how busy you must all be, so I'm looking forward to spending these 30 minutes with you and giving you as much information as possible about the Rotary Vane compressor. A couple of points before we start. For anybody who is listening who has more of a technical background, this webinar wants to be a very high-level webinar where we discuss about the technological aspects, but I don't go deep into these technological aspects. I will be making a dedicated webinar further along in time, maybe a couple of months from now or a month from now, where instead I will go into the very deep technological parts concerning this compressor. Thermodynamics, mechanical engineering, tribology, you name it. There's a lot going on in this very particular machine, and that will be dedicated for another webinar. So I hope not to disappoint with these basics for you more technical people. For everybody else, we're going to be following a path together. Do not worry about the speed at which I'm going. I want to keep this at 30 minutes. I know you're all very busy. I don't want to lose your attention. We are recording this webinar, and you will all receive a link once I have uploaded this webinar to YouTube, to our YouTube channel. And then you can look at it again. You can pause it, take notes, translate it in your language with YouTube, and that's also very good. So also throughout the webinar, please leave your questions in the question box. I believe there's going to be quite a lot of questions. Maybe at the end, if we have time, I will look for a couple of questions to answer. If we don't have time, those questions are very important for me and for my team. We will take them and we will build, hopefully, new webinars addressing these questions in the future. So let's get started. For those of you who don't know Mate and the Rotary Vane compressor, who is Mate? Who's speaking to you right now? Well, Mate, as you can see, is a 100-year-old company. We turned 100 last year. We've only ever been dealing with compressors since 1919. For the first half of the company's life, these were piston compressors, very large industrial piston compressors. And then, like everybody else, we moved to the rotary compressors throughout the 50s and 60s, and now we are our core business is rotary vane compressors. We'll talk about some of that later in the talk. So let's get started. I want to start initially actually claiming our big added value, and then I want to take you on a path of discovery to understand how we actually come with this technology to claim such an important added value. So our claim is that we have in the industry the lowest total cost of ownership of a compressor. Some of you who are listening might know this, some of you might not, but the cost of a compressor throughout its lifetime is like an iceberg. All right, so the very obvious costs are the capital equipment costs. So you got to buy the compressor, and there's a lot of negotiation always on the buying of the compressor. Most buyers are identify with how expensive is this compressor to maintain, so the maintenance plan of the compressor. But these typically only account for 20 to 25% of the real lifetime cost. The submerged part of the iceberg, the larger part of the iceberg that you can see here, this is the real issue, and it's typically how much it costs you to run that machine, okay, in terms of energy bill. So as an example, this is a very high level example, 75 kilowatt compressor, quite a large machine, medium to large machine. If this compressor works constantly, 8,000 hours a year for 7 years, we can estimate that buying it is going to cost you 60,000. Maintaining it is going to cost you the same amount over the 7 years. And then finally, the electricity bill is going to be 10 times more expensive than these at 800,000 euros. This is using 20 cents per kilowatt hour. So this gives you a feeling of how important total cost of ownership. But let's look at the question, how can we claim this? How are we? What are the basics around us as rotary vane manufacturers to claim something like that? So before we start that, let's look at the basis of air compressors. A very simple slide here explaining how the world of compressors is defined. On one side, we have the dynamic compressors. Dynamic compressors, axial, centrifugal, all sorts of other compressors. These are typically high-speed impellers or turbines which give pressure to the air that goes through them, mostly via kinetic energy. In our side of the business, we are into the volumetric compressor. So a volume of air is trapped mechanically by machinery. Then this volume of air is squeezed, compressed until the pressure rises from atmospheric pressure to delivery pressure. The most common type of volumetric compressor that all of us know is the reciprocating or piston compressor. If you have ever pumped up your bicycle tire, that is a piston compressor. Very simple machine. You pull out the handle, it sucks the air in. You push the handle, it compresses the air into your tire, right? On the other hand, the world had to move to a rotating style of volumetric compressor because the piston compressors were getting too large and too expensive for the requirements of the industry. And what happened in the 50s and 60s, the world moved from piston, most of the world moved from piston to rotary, and the screw compressor became the go-to item in terms of rotary compressor. There are many other volumetric rotary compressors out there. We won't go through them, but the vane compressor sits exactly in the same category as the screw compressor. So let's take a closer look at how this compressor actually works, the working principle. You can see here, this is a 3D image of our compressor. We have a stator, which does not move, as the word implies. We have the rotor, which turns, and we have the blades, which go in and out of the slots. Okay. It's a very simple working principle. This is a cutout. This is a cross section of the compressor itself. In this case, the rotor is rotating anti-clockwise. The blades are pushed outside onto the stator via a simple centrifugal force. There is no springs, no mechanisms. They are free to move. And as soon as this rotor starts rotating, you will get the blade flinging out into the chamber. This is an intake port. You can imagine these blades moving. You can see the volume here is small. As it moves, it becomes bigger. That making it bigger sucks the air in from the intake. As it closes, you have the maximum volume. As it goes around, it becomes smaller and smaller until it hits the delivery port at the right pressure. Somewhere along this compression, there is an injection. In this diagram, it's a simple, straightforward injection from the stator. We'll talk about oil injection later. That's why I'm mentioning it. But as you can see, a very simple working principle. The difficulty in designing and making this machine work, you will understand through the webinar, is all about the tolerances. It's all about the engineering and the know-how that goes in it. Okay. So let's start looking at the facts that make us so unique that we can make this claim in the industry. And the most important, maybe one of the most important, is all about the blades. So I like to call them infinite life blades, and you'll understand why. So the blades, there's a bit of misconception in the world about rotary vane compressors, and this starts usually around the fact that the blades wear out and then they need changing. So why would I want to buy a rotary vane compressor instead of a screw? Well, the truth, it couldn't be further from that. Everything in our compressor is made of a proprietary blend of cast iron. This diagram shows the blade, the stator, and the rotor. These three blends are slightly different. They have slightly different hardnesses. It's a real tribological marvel, which I'll go into in that other webinar in depth. But what happens here is obviously exaggerated. This is the oil film, this is the head of the blade, and there's absolutely zero contact between stator wall and blade head. Okay, this machine would never work if there was metal to metal contact. You can imagine it would only work for a few seconds and the whole thing would be absolutely welded together. This is an exaggerated diagram. In reality, this thin film of oil, which does all the carrying, all the pushing back of this blade, is actually the width of a human hair, 7 to 30 microns. Extremely, extremely thin. but because of hydrodynamic lubrication, it manages to do the job beautifully. Where is there metal to metal contact in the compressor? There is metal to metal contact on the side of the blade, but this actually is one of our unique points, which we will touch on later, and you'll see how amazing this effect is on the overall compressor. To give you an example, I'm going to use here a beautiful case study that was sent to us by one of our very long-standing and good clients up in Belgium. We have one of our old machines. You can see the design is very retro looking. This machine has worked non-stop for 30 years. 1990 was the service. It was put in service, and it was recently removed from service for no reason except to upgrade the client with a more efficient compressor from Matei. The amazing thing, these are the blades that have done the 30 years, 217,000 hours. You can see these were measured by the distributor, by our client, 42.85 millimeters in height. The 0-hour blades, these are straight out of our machining centers, 42.85 millimeters, again measured by the distributor. This is pure magic. A compressor that can work non-stop for 30 years in any environment. You can see here, maybe it's not even the cleanest of environments, is really something to be proud of. So let me put it in terms that we might all understand. Some people maybe 217,000 hours or 30 years. Some people don't know what 30 years feel like because they're lucky enough to be very young. So let's look at it in other numbers. The blade tip has traveled 18 million kilometers at a fixed speed of 85 kilometers an hour. Okay, that's 25 round trips to the moon, just to give you a little bit of frame of reference. So when I talk about infinite life blades, we mean infinite life blades. These do not need to be changed ever. Okay, let's look at the bearings. Any of you who are in this sector, any of you who work in the air compressed sector and know screw compressors, you know how important the whole discussion around bearings is. In a screw compressor, the bearings play a vital role. They keep the tolerances, they keep the rotors apart, they help with the axial thrust. And these bearings, unfortunately, at a certain point in the life of the compressor, they need substitution, they need remachining. The bearing housing needs remachining. Well, the beauty of the rotary vane compressor is we don't have any bearings. We don't need axial thrust bearings because there's no axial thrust. The machine is 100% balanced. The pressure profile between one end and the other end over the axis here doesn't have any pressure difference, so we can get away with putting two simple oil lubricated bushes, these items over here. These bushes, as long as there's an oil feed to these bushes, there is absolutely no necessity to substitute these bushes out ever. Okay, there again, misconception in the industry. Even our clients who go from screw to rotary vane, they end up thinking that after 5 years they need to change these items out. Well, this is really something that we keep trying to tell them to avoid at all costs because of what it could do to the compressor. Okay, moving on. So I've spoken now about blades and bearings. You can understand this is pure mechanics. These are items that don't wear. So we're looking more, that we're touching more that maintenance and reliability side of the total cost of ownership. Now let's move towards what actually makes us lower our energy profile, so much so that we can claim lowest total cost of ownership. Starting with the slow speeds. The slow speeds are unique to the rotary vane compressor. Why is this? Again, it's purely down to the design, the way the machine works. What we can afford to do with a rotary vane compressor, because we have 100% sealing between the highest pressure and the lowest pressure in the machine, we can bring that rotating speed down and we don't lose any volumetric efficiency. Okay. On the contrary, when you're dealing with a screw compressor, there is an intrinsic leakage internally between the high pressure and the low pressure. This leakage has even got a name. It's that common. I mean, it exists. It's called a blowhole. So once you have that fixed leakage, If you lower the speed of the rotors, that leakage becomes predominant and you lose volumetric efficiency. So very important point. We can afford to lower the speed of the machines, and in lowering the speed of the machines, high volumetric efficiency, but much less wasted energy due to friction, due to heat generation, due to noise, due to vibration and everything else that comes with it. So we're the only manufacturers of compressors that can drop our rotating operating speed below 900 even RPM for the operating life of the compressor. Let's look at the cooling. Cooling affects the thermodynamics of the compressor. Many of you may know that the biggest part of wasted energy in compressing air goes away in heat during the compression phase. So the holy grail of compressor manufacturers is to keep that compression chamber as cool as possible. Again, our design, our intrinsic design allowed us to adopt a technology that is quite widespread in the automotive industry. It's called pressure swirl injectors. This technology allows whatever you're injecting to be dispersed into billions of microparticles, adding an order of magnitude to the thermal exchange between the air and the oil, and the air is what you're trying to keep cool. We did this in conjunction with the University of Milano and the injector manufacturers. We patented this technology. We call it extreme injection, and we're the only ones in the field that can actually have a inside an effective inner cooling, inside the chamber cooling effect. This significantly decreases the energy spent for the compression phase itself. And here, finally, another point that is extremely important to understand. We're the only manufacturers of machine that actually improves the more you use it. This is something that sounds like nonsense, to be honest, but for over the decades, the Mackay team has known this. Our good distributors have always known this. Our clients that have been always loyal to us over the decades have known this. It was about time that we took some third-party certification around what we kept telling our clients, which sounded so surreal that one could understand why they wouldn't believe us. So what did we do? This was a very interesting test. We took a 55 kilowatt machine, one of those slow machines, the 1000 RPM machines. We send it into Intertek for a validation test. Now, Intertek is the same laboratory that CAGI, the Compressed Air and Gas Institute in the USA, use to independently verify the performances of compressor declared by compressor manufacturers. Okay, CAGI is an institution. Most of us who work in the compressed air industry know CAGI. We've been in for many years part of CAGI. Now, CAGI uses Intertek. We said, okay, let's go straight to Intertek. Donald over here and Clint over here, they are the people who test all the other compressors for CAGI. What did they find out? What did they find out with this test? It was a continuous monitoring test for 500 hours. What does that mean? They took the machine from us at 0 hours, they tested it at 0 hours, they ran it continuously in the laboratory. It was a pretty expensive test for 500 hours, and then at intervals of 100 hours each day, they measured the performance. They measured 1% improvement after 100 hours, another percent improvement after 100 hours, and another 1.6 improvement between 200 and 500 hours. You see there it's flattening. The curve is flattening there at the end of the 500 hours. They proved that this machine improves in its own energy efficiency. The kilowatts actually drop in front of your eyes to compress the same amount of air in the tune of 3.8% in 500 hours. In the laboratory for a larger machine, we measured up to 5%. But why is this possible? How is this possible? This is really, this defies all knowledge regarding compressors, industrial compressors, especially screw compressors. But we do understand why it's possible. Remember that polishing effect that I was mentioning on the side of the blade? Well, As that blade gets polished, as those 500 hours go by, the first 500 hours, that blade surface hardens, the friction coefficient gets lower, and we manage to save more kilowatts throughout the machine. So imagine a machine that's got bigger blades, bigger kilowatts wasted in friction. We are going to be running tests on the larger machines, tests like this one soon, but we assume, or rather we are convinced, that the performance increase will be even more important on the larger machines, so even beating the 5% improvement. So again, this is certified performance improvement over time. So finally, now that we've gone through all of this path of discovery, let me call it, how can we actually claim lowest total cost of ownership? Well, let's take it one part at a time. Let's look at the blades and the bearings that give us a so-called infinite life air end. Does that lower the maintenance cost of the machine? It definitely does. If you take into account the fact that every 4 to 5 years you need to overhaul a screw air compressor, and every 4 to 5 years you don't need to overhaul a Mate air end, a rotary vane air end, well, you can understand that over the course of 30 years you are saving 3, 4, 5, 6 overhaul, depending on the number of hours that the compressor is done, and that are big bucks in our business. They're such big bucks, these overhauls, that most of the time the client gets convinced to trash the 5-year-old machine and buy a new one. Well, this type of revolving spending, it's not the mission, it's not our core. At our core, we want our clients to enjoy our product for as many years as possible, keep maintaining it properly, and the customer should be happy. He should forget he has a compressor. He shouldn't remember every 4 to 5 years that he's going to need an overhaul sooner or later, or the whole thing will break down. For those of you who don't know, Mate compresses more things than just air. This is an air end for air. This is an air end for gas. We do all sorts of gases: biogas, methane, sweet, sour gas. We've got a lot of gas applications, which is a trending field right now. And also, this is our compressor dedicated for the brake systems in the rail industry. The rail industry has turned out to be one of the most one of the sectors that desires this type of long life and reliability more than anybody else that we have come across over the years. We've been selling to the rail industry as aftermarket, as retrofits for many years, and now the tier ones are in such need of different technology from what is currently being used. They have asked us to get IRIS certified, and in February this year we were certified IRIS. If you know what it is, it's the International Railway Supplier Certification. Very difficult to attain. So that is with regards to reliability and maintenance costs. But let's look at the energy costs again. Those points that we spoke about: slower speeds reduce energy wasted for friction, but also it adds reliability. You can understand a compressor rotating at 7,000-8,000 RPM, 3,000 RPM, even 1,500 RPM, versus something that rotates slowly over time. Everything gets more reliable. Extreme cooling, the pressure swirl injectors that we spoke about, these reduce drastically the energy wasted through heat of compression. This is the #1 killer with regards to the wasted energy of an air compressor. Whoever will be able to go close to isothermal will have the perfect machine, which is impossible, unfortunately, but we're trying to get there. And then finally, the improving performance, the certified improving performance over the first 500 hours. This is absolutely groundbreaking stuff. No other machine is going to be measured over the first 500 hours, and you'll discover that there's an actual improvement in performance. So can we claim lowest total cost of ownership? Of course we can. The machine gets better over time and then gets stable. This is a little teaser that will be the basis of a whole new webinar, another 30-minute webinar that I'll be making soon. In this teaser, we are adding a little bit of information. Hey, if we need to change those bearings out, if we need the overhaul on the screw compressor, does that mean that screw compressors performance drops over time? Of course it means that, because the screw compressor performance is linked to the tolerances of those bearings. It's linked to the machining of those bearing houses, all right? And that's why you need to change at a certain point. You start putting in that difference, 2%, 5%, 10% different deterioration over 40,000 hours, and the gap is huge. The gap is huge. And look at that, they're both starting at the same 0-hour energy efficiency. All right, but this is a teaser. I'm not going to go into this, and I hope that you'll be joining me soon for this webinar. So I've tried to keep within the time frame. I know I spoke fast. There was a lot of information to show you. The last thing that's left for me to do is thank everybody for your time. I'm very grateful for your attending this webinar and listening to these hopefully interesting facts. There's going to be a very brief 3-question survey at the end of this. Please find the extra 2 minutes to answer that. It's very valuable feedback. And please follow us. We are not very well known. We need to get the message out there. We have a brilliant product, 100 years of history, and now is the time to inform everybody out there that there is a solution to this air compressor industry, when we can stop throwing away money at new machines every 3 or 4 years. Follow us on LinkedIn, on Instagram, on Facebook. Those are our go-to platforms. We create new content every day, 1, 2, or 3 pieces of content every day. You'll see a million different uses of our rotary vane compressors in different applications, industrial and special applications. We're very proud of everything we put out on social media, so please follow us. Now, having said that, let me check if there are any questions that have come through. Oh wow, there's a lot of questions. So if you can bear with me, we have a couple more minutes. We have about 4 minutes. Let's see if I can pick up a couple of questions. Well, there's a simple one here. I'll answer this one. What is the highest pressure you can reach with rotary vane compressor? It's a good question. We match the standard industry, the widespread industry. So 12.5 to 13 bar. We are working on applications up to 15 bar now, special applications. But those are really what we call custom engineered solutions. So we've pushed ourselves to 15 bar over the time. Let's see. Recommended. Okay, recommended lubricant for rotary vane compressor. This is a good question, right? I spoke about how important the lubricant is. I will definitely be addressing the lubricant in the deep dive into the technology side of things. But in the rotary vane compressor, because of what I told you that lubricant can do, those 7 microns to 30 microns, it's quite a complex blend that we work with constantly on with our suppliers. So we really do not advise to use any other lubricant than ours. But if you have to, if you're in a situation where you cannot get your hands on the lubricant, just make sure that you use a lubricant that has some specific technicalities that we can definitely send you, but you do not leave that lubricant in for as long a time as our original lubricant. All right, the biggest difference is that our lubricant has been formulated to last a long time, and versus many other lubricants which suffer the stress of working inside a rotary vane machine. That's one thing that is definitely very important. And finally, there's 2 more minutes. This one is a good one. Is your compressors air cooled or water cooled? We have both. Our price list. You can have water cooled, you can have a heat recovery, or you can have air cooled, just like the majority of the large manufacturers out there. Let's see. Okay, there's a good one here. Let me see. Why opt for rotary vane compressor if screw compressor fits equally fine? This is a good one. Well, I hope this was added around halfway through the webinar. I hope the rest of the webinar explained why we believe that having a machine that you don't need to do overhauls, that you don't need to substitute every 5 years, a machine that will not consume as much energy as over the course of its lifetime as a rotary vane. Those are important for your clients. If you are distributors and you're listening, a client is happy to spend less. A client is happy to know he's buying a machine that can last him a long time. And so these are really what really drives us. We want to give the best solution, the most energy efficient solution, but we also want to make sure that this machine will last in time. Okay, I don't think I can answer any more questions. There's a lot of questions, and hopefully we'll be able to go through all of these and maybe address. I see some of them are quite technical. I see that we're going to be working on these with my team and hopefully getting back to you in other webinars. That's it from me. My timer tells me it's 30 minutes. I hope you enjoyed and understood this webinar. And again, there's 3 quick questions at the end of it. When I close, you will be receiving an email with the email you registered with the link to the video after this. And I look forward to seeing you again for the next webinars organized by Mate Group for Rotary Vane Technology. Thank you. Bye-bye.